So just because you can draw a redox reaction on paper doesn't necessarily mean that it would occur in the order or in the exact direction that you're drawing it. For example, what I'm showing here is actually two different reactions, and one is just the reverse of the other. All right. So obviously both of these reactions would not likely occur. One of them would be the one that would be likely to occur. It's only going to occur in one direction. All right. So which one would be the case? All right. So the way that we're going to do this is by using what's called an activity series. All right. And this might look familiar from sophomore chemistry. The only difference is we didn't talk about oxidation reduction in sophomore chemistry. In this case, we do. So essentially the way this works is that the higher a metal is on this particular list right here, the more likely it would be to get oxidized. All right. So lithium is highest on the list, so let's compare it to something way down on the bottom of the list, like gold. All right. So what this means is that lithium would be way more active, or sorry, way more likely to get oxidized than something like gold. Gold metal is not likely to get oxidized. It's not likely to lose an electron and become gold ion. All right. And hopefully that would make sense. That if you take a look at the things at the bottom here, you see things like palladium, platinum, gold, things that they tend to make jewelry out of. All right. And if you think about it, what kind of metals would make nice metals to make jewelry out of? Things that would react and become ions, or things that don't. All right. We don't want metals reacting when you're wearing it as jewelry, and that's why these types of metals down low on the list tend to be the types of things that you would make jewelry out of. Obviously, you're not going to do it out of mercury because that's a liquid, but these are your precious metals down here. So how are we going to apply this to the reaction? All right. So what you're going to want to do is take a look at your reaction and identify the metals that are involved. All right. And in both of these reactions, we've got lithium and sodium. So let's go ahead and draw them as being oxidized from their pure metal form. All right. And one way to indicate that you're talking about the metal form as opposed to the ion form is to put a little 0 as the charge. All right. So what I've done is drawn both of these as the oxidations, and we want to say which of these oxidations would be more likely to occur. All right. So lithium is higher than sodium. So what that means is that this is the oxidation. If you gave these two metals a choice, this oxidation would be more likely to occur over this one. All right. So that's higher. So this right here would occur. This right here would not occur if it were in the presence of lithium. And not only would it not occur, the reverse of it would actually occur. All right. And so when you do the reverse of an oxidation, that would be a reduction. All right. So if I show sodium ion plus an electron becoming sodium metal, that would be considered the reduction of sodium ion. All right. So what we want to do is find which one of these two reactions shows lithium getting oxidized and sodium getting reduced. All right. Well, that would be the one on the left. We've got lithium 0 here becoming lithium plus 1 as a product, and you've got sodium plus 1 becoming sodium 0 as a product. All right. So one thing I just want to point out, you'll notice that nothing happens with the chloride. You've got Cl minus here, you've got Cl minus here. So nothing's actually happened to that ion. So it would be considered a spectator ion. All right. So I do want to point out that this reaction right here would still probably not occur. It would not occur as an aqueous solution. Sodium metal would react with water. It is possible though that if we were able to melt lithium metal, which you could do if you heated it up enough, it is possible that this reaction could occur. So to practice this, what I've done here is I've given you a couple of different reactions, all right, where the thing on the left is just the reverse of the thing on the right, and the reaction would be likely to occur in one of the directions. All right. So How are we going to do this? Well, first of all, we need to figure out the whether an oxidation or a reduction is occurring. So what I'm going to do here is just show the oxidation number of all these metals. And then what we're going to do is just say, all right, let's identify the metals and find where they are on the activity series. All right, so we've got sodium and magnesium here. So sodium seems to be higher than magnesium. So what that means is that sodium is the metal that would more likely get oxidized compared to magnesium. All right, so if sodium is more likely to get oxidized, we want to find the one that shows sodium being oxidized. All right, so in this case right here, we've got sodium going from 0 to a +1 oxidation number, so that shows sodium as an oxidation. All right, and as we mentioned before, if the lower metal would actually occur as a reduction. All right, so magnesium going to magnesium 0, that's a reduction. So in this particular case right here, this would be the reaction that occurs. All right. So what I want you to do is pause the video for a second, and I want you to try to make predictions about these two reactions right here. Okay. So in this case right here, we can show the oxidation. Let's go and show the oxidation numbers of all these. All right, so we need to compare cobalt and potassium. So cobalt is right here, potassium is way up here. So we want to find the one that shows potassium being oxidized. All right, so potassium, that looks like it would be right here. Potassium going from 0 to +1, and cobalt would therefore have to be being reduced. So this would be the reaction that would occur. This one right here would not occur. All right, and in this case right here, okay, let's compare zinc to copper. Zinc is right here. Copper is right here. So zinc would be the one that would be more likely to be oxidized. All right, so which one of these shows zinc being oxidized? That would be this one right here. All right, and some of you might recognize this reaction. This is actually a very famous reaction, and we're going to be talking about that in the next video, because this reaction is actually the reaction that forms the basis of how batteries work. Right. So one other thing that we can do to practice predicting what would happen is, instead of giving you two separate reactions to pick between, let me just show you a couple of different reactants. All right, and what we want to do is say, all right, let's say that we had nickel metal, nickel bromide, aluminum chloride, and aluminum metal. All right, which two of these could we mix together so that we could get a spontaneous oxidation reduction reaction? All right, so what we want to do, if you take a look at these reactions here, notice that we always have an ionic form of a metal plus a pure metal on each of the sides. All right, we never have the pure metal on both sides of the reaction. So we could rule off the bat that it would be nickel and aluminum. All right, so it would either be nickel and aluminum chloride, or it's going to be aluminum and nickel bromide. All right, so which of those is it going to be? All right, well, let's take a look at where these are. We've got aluminum right here. We've got nickel right here. So aluminum is going to be the one that we would expect to get oxidized. All right, so we want, since it's going to get oxidized, we want to show it as the pure metal on the left-hand side of the reaction. All right, so looking at these oxidation numbers. All right, so we would want to show aluminum as a reactant. All right, so if we have aluminum as a reactant, we want to show the material that has nickel in its charged form. So this is the one that has nickel in its +2 ionic state. All right, so you would accurately predict this to be involving these two reactants. All right, so we've got aluminum and we've got nickel bromide, and if we want to predict the products, this is gonna be a single replacement. So the aluminum is, once it's in its charged form, is going to have bromide as its negative ion. All right, and if we balance everything out, this is the balanced reaction that we would get. All right. One thing I want to point out in this reaction, which we didn't show up here, is that it's not necessary that the negative ion be the same. All right. Actually, all right, you'll notice that in some of these I've got nitrate as the negative ion. That's actually a negative polyatomic ion. Sometimes we've got bromide, all right, and here we have sulfate, and it really doesn't matter, all right, as long as the metals in the reaction can be found in this activity series. That's all that matters, and we can have whatever negative ion we wanted to there.